Okay, in this video I'm going to look at some error analysis for problems number 39 and 40. And what we mean by error analysis is that we are looking at a problem and then we're looking at the way that some student went about solving that problem but made an error in the process. And it's helpful for us in learning ourselves to look to try to identify what that student did wrong, because if we can identify what somebody else did wrong in a problem, then we will learn not to make that same mistake ourselves, and possibly what that student did incorrectly we would also do. So this is going to help us to identify errors in other people's reasoning so that we don't make those mistakes ourselves. Alright, so in problem number 39 we start with the equation negative 0.8 plus r is equal to 12.6. Now, based on the properties of equality that we learned about in this section, we are trying to isolate the r to see what r is equal to. And in order to do that, we have to get rid of, or we have to subtract, multiply, divide, add, etc. The other pieces of the other quantities that are related to r so that we can isolate r. Now in this case, what we would do is we would add 0.8 to both sides. And when we do that, we would get r is equal to 13.4. And so that's the way often with doing error analysis we might want to work through the problem ourselves and to see how we would think about it, and then go and look at what the student in this particular problem did. And here we can see that the student did add to 12.6, but they added a negative 0.8. So we're not trying to add a negative 0.8 to both sides. They did it correctly on the left side because they ended up with r, but on the right side they added a negative, which we know is the same thing as subtracting, which we should have when we should have been adding. So they should have been adding, and instead they did something equivalent to subtracting 0.8 from the right side, whereas they added 0.8 to the left side. How do we know they added 0.8? Because the negative 0.8 went away. It zeroed out. The only way that could happen is if you added 0.8 on the left side. So the student's mistake here is that the student added 0.8 correctly on the left side of the equation, but added negative 0.8 on the right side of the equation. So that's where the student's mistake came in. Let's take a look at number 40 then. In problem number 40 we have negative m divided by 3 is equal to negative 4. So our variable m is being divided by 3. We could actually say our variable m is being divided by negative 3. Even though the negative is not put into the denominator, that's what's happening. And so to undo this, what we would need to do is to multiply both sides by negative 3. And when we do that, we should see that a negative times a negative is a positive, and the 3's cancel out. The 3 divided by 3 becomes 1, and we're left with an m on the right side, and negative times negative is positive, a positive 12 on the, an m on the left side and a positive 12 on the right side. Now let's go take a look at what the student did in this particular case here. So we're looking at the second row there. And in this second row we see that the student actually multiplied both sides by 3. Now, the multiplication property of equality says we can as long as we multiply both sides by the same thing, we still end up with an equivalent equation, which means we end up with another equation that has the same solution to it. So it's not wrong that the student multiplied by 3 instead of by negative 3. However, when we look at what happens here, you notice that the 3 times negative m over 3 is a positive times a negative, and what should result from that is a negative m. However, the student put a positive m. On the right side, they did it correctly. 3 times negative 4 is negative 12. So our analysis here is that the student multiplied both sides of the equation by 3. And they did that correctly. However, when they simplified the expression on the left, they should have got negative m. And instead, they got positive m. And that was a mistake. All right, so we'll end this video at this point here.